Good afternoon. I'm Ron DiIulio, the director of the UNT Astronomy Program. Today we're going to discuss the Rosetta Space Program. The Rosetta mission has an interesting background. First of all, it's named after a famous Egyptian stela, a little message board on which there were some information that was written in Egyptian as well as Greek. And with that, we were able then to figure out what those words in Egyptian were from the Greek, and that was kind of that famous Rosetta Stone we talk about. That was the Rosetta Stone. They have named this mission after that because we're hoping that what they learn from this mission, which will in fact orbit the comet for over a year and just take very, very high resolution images of the comet. It will stay with it and we'll get pictures to see not only what it was like one time, but how it is and how it changes over a period of a year, which we've never done before. During that time, we'll find out if, for example, in a comet, you have all these porous areas and inside of the comet, things like water and that comes out. And then as this thing warms up, it expands and those little porous areas get larger. And the dust and the gases and the water that's in here then escape. And that's the tail we see of the comet. And so that's what they're going to be studying. And over a year, we're going to get to watch a year's worth of activity, which should tell us much about these comets that we know really very little about. Now, specifically, this comet is also interesting because just recently, as the European Space Agency got close to the comet, they discovered something, that this comet was shaped as if it had been two comets or two rocks that collided. And so by looking at this, we're going to find out what actually is a comet. Is comet perhaps maybe just another asteroid? And in fact, we pretty well think now that we are looking at leftover debris like an asteroid that has been way out in space. And because of that, there are frozen gases and things from our primordial beginnings that should tell us what our solar system was like in the very beginning.